Hey folks, welcome back. Going to take a break from motorcycles for a bit. We're going to do a small job, hopefully a small job here, on a 2003 Rancher, Honda Rancher. That's a TRX350TE, and that's the the official model number. It's an ES Rancher, and it's a 4x2. And the problem with it is the main customer complaint is this has electric shifting, and it's locking itself out with an error code after you shift it a few times from a cold run. So in other words, you don't run it for a while, you start it up and it shifts fine, you go first, second, third gear, and all of a sudden it will not shift anymore, and whatever gear it's on the display, which is very hard to read by the way because it's washed out, this LCD starts flashing, constant flash. All right, there's your shifters up there on the left handlebar control, up and down. And so that is the main complaint. He said that he's done some research on it himself and found something to do with the angle sensor and something to do with the ECU. And I said, well, it's possible. It certainly could use an ECU. And I was thinking that right off the bat, the way the thing was behaving, the way he described it. So I've already started some diagnostics on it and actually shooting this intro afterwards because I had an intro, but for some reason it didn't record. So I'm doing it again so we won't just jump into it. You at least know what we're doing. So yeah. So anyway, the first thing we want to do in any kind of a situation or a case like this is to verify customer complaint. So I did that, and after driving up and down the driveway a couple times, sure as hell, it stopped shifting. And I was getting the flashing beep beep of the whatever gear I was in, second or third or whatever, and it would not change on its own. Now luckily he provided the manual shifter guy. Well, it comes with the unit, I guess, for emergency purposes if you're out in the backwoods somewhere and it won't shift. You need to get back, you can put it in second or third and let that CVT type clutch in there handle the start and stops without it destroying itself at least, and you can make some reasonable speed. So I was able to do that because unfortunately I stopped the engine out there like a moron and then couldn't get it restarted because of the interlock. So I got it into neutral, and the funny thing about it is it will go into first. So if it locks itself out and then it won't shift, you shut it off, go into neutral manually, and then when you turn it back on, you can hit the button up and it'll go right into first gear. So it's kind of weird that it's only doing it when you go up in, a few gears. And then once you get into first, it'll actually shift from neutral to first, like I said, with the next ignition cycle. So yeah, like I said, I verified the complaint. The other thing we're going to do is an oil change and a filter on it. That's nothing I'm going to film, just regular maintenance. He wants that done. And anyway, but what we're gonna deal with in this video is the diagnostics and going through the troubleshooting in the service manual on trying to figure out what the problem is with this electric shifting. So with that, let's get right on it. So the way this works is, according to the service manual, when the electric shift or ES system shows a possible fault and the ECU picks it up, it tries to reset that system, and it'll reset the system pretty much the same as if the operator cycled the ignition, so off and back on. So it tries that at least once. It doesn't specify how many times, and if it fails to be able to reset it, in other words, the error still persists at the ECU, then it starts to set the code flashing and it disables the electronic shift or electric shift completely. So there's no way you can use it. And so essentially when you're to the point where you have a flashing N and then you don't have any function of the electric shift, you are already at the point where it's locked itself out because there is a hard fault. So there might be a little soft fault once in a while where maybe a sensor, I don't know, gets wet or something, or temperature variance, and then it resets itself and everything's hunky-dory. That happens with electronics. But if this thing locks it out and it continues to lock it out and flashes a code, then we have a hard fault and then has to be diagnosed by reading the codes, which is what we're going to do next. All right, folks, we're going to go ahead and read these codes here. And the way the factory service manual says to do that is we're going to do a couple things at the same time. I'm going to have to put you down for it, and I'll pick you right back up to see what it reveals. First thing is, you press and hold both up and down shift buttons at the same time whilst you turn on, you hear, like that word whilst? I figured our UK friends would like that, the ignition. So these are depressed while this goes on, all right? Before the neutral indicator shows up, which is very, very difficult to see. I can just turn it on right now and you can see, even with the glare sucks. I mean, I'm trying my best, but it's very, very faded, so because it's washed out. Before that comes on, you release and then repress, both buttons at the same time and hold them for 3 seconds. Then it'll start flashing. All right, now I've already done this once to get it right so I can show you, and I already know what the code is, but I want to go through the reading of the code with you. Now the way these codes work is very similar, like I said before, to an OBD1 system, where when you shorted 2 wires together, turned ignition on, it would generate a flashing MIL, malfunction indicator light or idiot light, and it would be a pulse like that. It looks like a square wave on an oscilloscope. So each pulse indicates one flash. In this case, it would be code 33. So 3 and 3. All right? So you get where we're going on this. So what I'm going to do is I'm just going to put the camera down here, leave it recording, and then I'm going to do the rest of it and then show you the results. Well, I'll try it this way real quick, then I'll swing the camera around so you can actually see what it's doing. It's going to reflash the code multiple times anyway. All right, so I'm going to push both of these buttons down at the same time. Turn ignition on. Before that goes to neutral, release, and push them again. See it flash once. Now it's starting to flash. All right, let me get you off the mount here and see what it shows. The solid N is a break between the sequences of codes. So that's 3, 6. Then there's a solid N. That's the break. 1, 2, 3. 1, 2, 3, 4, 5, 6. So it's repeating a 36 over and over again. If there was a different code, or multiple codes, I should say, after that solid N, the second set of codes would flash. In this case, again, right after the N right there, 1, 2, 3, 1, 2, 3, 4, 5, 6. All right, so we know it's code 36. Okay, this is what happens when you don't look at the codes before you say something. That is 2 separate codes. I thought it was a 36. It's a 3 and a 6. Either that or that one code, I don't know. You know, this is really weird. Either that or that one flash in between is a 3rd code. ECU writing and recording circuit. 1 flash, but it's a different length flash, so I'm going to go off of 3. I'm going to go with 3 and 6. So 3 is angle sensor system, angle sensor abnormally installed or related wire harness or ECU. 6 is ECU fail-safe relay circuit, ECU. And I told the customer, I said, this smells like an ECU problem just by looking at it. So we're going to have to look into the rest of this section now and see what you're supposed to do with each of those 2 codes for the angle sensor system. And I'm not sure if that's a single blink for ECU writing and recording circuit. I don't know. But if it is, that would make sense because it's an ECU failure. This is also an ECU failure, and this is connected to the ECU. I think I'm telling you right now, my gut's telling me the ECU is bad, which is what I thought when he dropped it off. Anyway, I'm going to flip through the pages here. Sorry about that little confusion. So it's not a 36, it's a 3 and a 6. Program code 3, 8, and 9. So we're going to start with 3, which is an angle sensor system code. And so what we're going to do is just follow the algorithm here. And essentially, they show you in a little picture here where the ECU is, which is in the back right. There's the regular rectifier, and then right kind of in front of it is the, or behind it rather, is the ECU. So that's where we're at. We're in the back corner. And it's going to be hard to show you this. I'll just show you where it's at. And what I'm going to do is I'm going to pull the regular rectifier out of the way and take the ECU right out. Hang it over to the side because we got to take a plug off the ECU. I'll disconnect the battery first. Inspect some of the wires while we're in here because the reason why I want to do that is I forgot to tell you this. The owner said that he pulled a mouse house out of this thing. So, and it was in the back here. Like it was under the seat, something like that. So it's quite possible some wires got damaged or chewed up. This harness looks like it's been unwrapped though, which is kind of interesting. Yeah, let me get this stuff out of the way. We'll pull the ECU over to the side because it's just mounted on rubber anyway. You just kind of push it out of the way. A little silicone helps when you're doing that. And then we'll hang it over the side. See if I can get you in here as close as possible. We have to meter up the resistance on 2 of the wires, which I think it's just 2, which goes back to an angle sensor, which is mounted way down in there, which we'll go to next depending on what the reading of this is. All right, so hang on. I took the wheel off, easier to get at. And I've got the ECU dislodged. Battery is disconnected too, by the way. Well, nothing jumps out. Nothing to say that there's a problem down another part of the harness though. All right, we gotta undo the 22 pin connector, which is the big one. Should be able to release it, but these things are very often, I mean hit the release rather. These things are very often very, very hard to get out. Oh. These weather pack style connectors have a gasket in there, and sometimes the gasket is putting outside force, you know, pushing outwards, so it won't let the thing release. Okay. It's just really stuck. All right, I'm gonna have to work on this off camera and then come back. We'll have it out hopefully. All right, here we go. Just is stuck. No bent pins, that looks good. All right, so we want 2 wires, which are we want to test between the black with a red stripe and the blue with a green stripe terminals. It does not give us terminal numbers. So again, black with a red, blue with a green. Okay, we're in auto range, resistance, black with a red, blue with a green. One thing you don't want to do is really jam these in here. You can screw them up as far as the pins go. What we're looking for is 4 to 6 kilo ohms. 5.096 kilo ohms. We wanted 4 to 6, so that's good. Yeah, so hope my arm's not in the way. 5.097. So again, 4 to 6. So it may be on the high, well, not really. It's pretty much just over 5 kilo ohms, so that would be almost dead square in the middle. So I'd say that's pretty good. So that test being passed says to skip the next one, which is, you know, the yes-no algorithm. Go right to the angle sensor. The angle sensor is down in there, if I can get you in there to see. I'm gonna have to turn you sideways to see it. There's the angle sensor down in there. You can see the plug. There's a blue with a yellow wire. Now it asks a simple but dumb question, dumb for me at least, because it says, there it is the angle sensor mounted correctly? Well, I don't know. Is it? Sure as hell does. Looks like it's mounted correctly. I mean, it's there. All right, the next thing we're gonna do is a continuity test. This is the wire from the angle sensor, the plug rather, the connector. And there's a yellow with a blue on here, and I'm already tapped into the yellow with a blue on that 22 pin connector that we just played with before. So I'll set you up. You can look at the meter. I have it set on continuity and beeping. It'll go beep. So if that's the case. So you tell me what it's saying, okay, in case I can't hear it. So I'm on the yellow with the blue, and we've got continuity. I'm curious to see what the resistance is, though. 0.14 ohms? That's fine. 0.07, yeah, 0.08. So, well, it's jumping up because of connection on my end here. Yeah, so that's perfect. That's fine. There's really good continuity between those leads there. Yeah, so I'll reset this. And where do I go? Ohms, there we go. So yeah, this is good. That circuit's good. Let's move on to the next thing. The test right after the last one I can't do because it requires a special tool breakout harness. It's to test the voltage on the angle sensor, but unfortunately, like I said, I can't test it. So we're going to move on to the one after it, which is an angle sensor inspection at the ECU connector, which is a resistance reading. And what you do is you hook up to the yellow with a blue and blue with a green, which I've already done on the wire harness side of the ECU connector while shifting through all the gears. So right now it's in neutral. So I don't have any reading at all. So if I'm hooked up to the right wires, then... All right, we got some sort of reading now from this. I had to jack both wheels up. That way I can turn the rear wheels because it's posi traction. You can't just do one side. The reading is supposed to be 0 to 5 ohms. And we're in the kilo ohm range, and it's jumping all over the place. As soon as I touch this little lever and move that shaft a little bit, it just jars it a little bit. This thing goes haywire. 43, 24, yeah. And I'm on the 2 wires I'm supposed to be on, so I would say that we got a problem in this angle sensor for sure. Let's go down now. It's supposed to be the same on all the gears. Now we're in neutral now. Yeah, I think that you touch this and it goes all over the place. I think the angle sensor is bad. Let me reach in here and wiggle the angle sensor itself. I'm pushing down on it now. Sort of stabilizes, then you wiggle it and it starts going all over the place. Yeah, I would say the angle sensor is bad, so I'm just going to go with that. Yeah, because this resistance on the angle sensor circuit back at the ECU plug does not jive at all with 0 to 5 ohms. I mean, that's way up there. So I would say that angle sensor is trash, and I'm definitely on the 2 correct wires. All right, so I think that pretty much takes care of error code 3, and I think there's some universal consensus here the way this meter was bouncing around, especially if I could touch the connector or even just the shift lever a little bit. It'd just go all over the place. And I double checked the little test wires I'd put into the plug, and they weren't wiggling around. So I think that is the angle sensor. We're going to go ahead and replace that. But there's another error code we have to deal with. Remember, that was a 3. Now it's error code 6. So a 3 and a 6. So let's talk about 6. This is on page 2214 of that 19 pages of service manual data on this ES or electric shift system. All right. So problem code 6 or 7. 6 is the ECU failsafe circuit, and 7 is ECU voltage convert circuit. I don't know what that means, but as far as failsafe circuit goes, it's almost like an ECU check. So in other words, if this thing was flashing a 6 all the time, then it would be ECU failure, I guess. But I'm not really too sure about that. But I can tell you that this is a little confusing the way they write it, but I think I understand what they mean. So the first thing is ECU system failure checking, all right? Check the electric shift failure. The gear indicator blinks when turning the ignition switch from off to on. Well, we already know that happens. So it's a yes. Go to step 2. Step 2. So number 2 is check the problem code, okay? Check the number of blinks, the problem code number. We've already done that, 3 and a 6. Does the gear indicator blink other than 6 or 7 times? Well, it does blink 6 times, but it definitely does blink other than 6 times. It gives us a 3 and then a 6. So yes is troubleshoot rather than problem shoot. The heat's getting me. Troubleshoot the problem code when we've just done that, okay? If it's a no, let's say it was only firing off a 6 or a 7 and no 3 in there, replace the ECU, the new one, and troubleshoot again. I think what this means is when it fires off a 6 or a 7, it's an ECU problem. But if it fires off another code with this, indicating the ECU is not happy, then you diagnose that problem code based on how many flashes it is. So again, we had a 3 and a 6. 3 is the angle sensor, and we did that. That's how I'm reading this. So again, I believe if it was only flashing a 6 or a 7, we would be, already inside ordering an ECU. But since we have other than 6 or 7 with 3 flashes, we have to say it's yes. We've already diagnosed or troubleshot that problem code, and we believe that it's the angle sensor. So at this stage, I'm going to say that it's a very low probability that the ECU is bad, although it's still a possibility. But I'm not saying we're throwing the parts cannon at this thing, but the data is somewhat, not concrete, because we were getting some really funky numbers off of that angle sensor reading based on that last test for error code 3. but I still believe the angle sensor is bad because of that. And the fact that we got an angle sensor code at all is indicative. You have to kind of look at it from its simplest terms, you know. Simplest thing, or the most explainable thing or obvious thing is going to be the problem or the solution, as the case may be. I know I'm bastardizing that, but sometimes you got to look at it from a simplistic point of view. It was firing off a code 3, so that's angle sensor. So we're going to replace the angle sensor. And it was also firing off code 6, which apparently is an ECU failsafe, but maybe it does that anyway because the ECU is reporting that it's not happy about a number 3 code. So that's how I'm interpreting that, and that's how I'm going to stick with it. So I'm going to go inside, go take a shower, sit down at the computer, try to find an angle sensor for this. I don't know if they're available new or not. It's possible. See how expensive they are. Going to get it ordered in, and then we'll throw the angle sensor in. It's pretty easy to get at, right up there in the front of the engine. I'm going to probably do this resistance test again with the gear shifter. I'll report back my findings on that with my fluke at that time. It's going to be a number of days before I fire this back up, maybe even more than that, depending on how long it takes to get one. But we'll continue the video at that time. Well, I figure while we're waiting on that new angle sensor, I might as well just take the old one out. Take a look at it on the bench. See what it looks like. See if there's anything obvious with it. So I'm going to go ahead and take the plug back out if I can get in here. This is not the easiest thing to get at. It's pretty easy to get at right up there in the front of the engine.
It's pretty easy to get at right up there in the front of the engine.
Can you guys tell me how many M10s are in there? Because I can't see. I don't know why the hell they put it. Well, I understand why they put it there, because apparently it measures the angle of the shifter here, where that is. You know, in the rotation. That's the way I'm interpreting it. It is too, yeah. I'm learning as we go along here. I've been reading all the instructions and, not the instructions, the service information, and I think I got a pretty good idea what they're talking about when the operation of this thing. You may have to do it the old-fashioned way. It looks like one. There's like a cover on it. There's another one underneath it that actually holds the sensor in, but I'm not sure. Jesus Christ, there's no room in this place. All right, we're gonna have to go old school. I cannot get anything in there, it's too tight. I mean, this is really tight. Get a wrench on it if I can even do that. I mean, unless you take half the bodywork apart. And of course, it's too close to the bracket to get a ratchet on. A ratchet wrench, that is. You gotta be kidding me. Not even tight, actually. Yeah, this isn't tight at all. The service date on this, and you would think that there would be some sort of a clocking procedure for this sensor. You know, like on a more sophisticated setup in an automobile or other vehicle, it would have almost like a relearn, you know, for it. Let's see, it looks like 2 8s maybe? Other 10s. Yeah. You'd think there'd be some sort of a relearn or something, you know, but I don't really get that out of the service data as to what you're supposed to do with it. No, that is not a 10. Must be an 8. I thought it was. Looked like an 8. But, you know, it's hard to see. What in the hell size is this? One. It is just not easy to get at. Let me tell you what, this is one pain in the ass sensor to get at. Oh man, that's stuck too. I had to take the inner fender out on the left side. I cannot get in here otherwise. I guess I probably should have read the... Well, I did read the service date on it. Didn't say anything about that I remember. So it's just hard to get at. It's one of these sensors that is shrouded by, you know, protective stuff and, you know, pieces like not shrouds, but covers and things like that. Oh my God, that is stuck. Holy crap. This is just ridiculous. There it goes. Jeez. And there's an O-ring here. I hope the new one comes with that. Yeah, a little oil is gonna drip, but it's no big deal. Yeah, see, there's but you can see on that, on the end of that shaft is a little flat on it. And so right now it's in neutral. And so that's the neutral, obviously neutral position. And you can see the sensor right there has got a likewise, you know, flat in it. It's a little clip actually, brass clip or something to make that flat part, because otherwise I believe it's round. Yeah, so I'm not really sure if this needs to be clocked. So before I turn this, or, you know, otherwise examine it, I'm gonna go ahead and see if it turns like clockwise or counterclockwise, a certain number of turns before it stops, and we'll just reset the new one the same way. This is very strange that it's got a clip on it that could be, I guess, set up in whatever setting you want. You know, this, and there's no guidance in the service data about this. So let's go from this position, make a note of that. Yeah, it barely goes, let's say, to the 10 o'clock position when it's down like this. Then it stops. So it was about right there when we started. And then it'll go all the way over to about the, was that the 4 o'clock position? So yeah, this thing only has a certain amount of range. But apparently there's no way to put it in wrong, because with that limited amount of range and the thing, you know, sitting in neutral, it has to line up this way. So we just clock it this way and then put it in, and it should work. What I'm kind of curious is if we put a meter on this and start turning it manually to see what kind of feedback we get. You know, the resistance on this is going to be what that little ECU unit is looking for, to see what gear it's in. And like I said, angle sensor is kind of misleading. Angle's like the angle of the ATV, but it's not. It's obviously the angle of that shaft relative to the gear you're in. So this is telling that ECU in the back, which by the way is only for this function. I was under the impression that might be the ECU that covers like everything, you know. It might have an electronic control unit for ignition and everything. But that is on the other side, a CDI for the spark and everything. What that box over there does is exclusively everything up here, because it's all digital. And if you think about it, that makes sense. Because, you know, you have no analog, you have no mechanical gauges or anything whatsoever. Any odometer, like for example, odometer trip here, no mechanical resets for that, no mechanical shifting except for the emergency shifting, all push button. So, you know, it's basically drive-by-wire as far as shifting goes, and then reporting the status of things like the gear you're in. Obviously the speedometer is digital. That's why there's a speed sensor in this circuit. And so I was looking at it last night, looking at the wiring diagram. I thought I printed that out, but I didn't. I only printed the troubleshooting out. This is on the page before it starts. So here it is on the screen. You can see all the, you know, the sensor inputs on this electronic control unit, ECU. And again, there's nothing in here for ignition except ignition switch where you get power into it. It all has to do with that display up there, except for the fact that there's a pulse generator, so it knows when the engine's running, because this is also for interlocks. So what this is doing is it's cutting out the ignition when it's not in a certain position for starting. For example, it's in gear and the engine's off. You turn the key and nothing happens. And I did try that when the sensor was blinking that code, and it wouldn't let me start it up, and I had to mechanically move it into neutral. It also gives you your neutral light and your reverse. Where is that? There's a reverse light or a reverse gear sensor on here as well somewhere. Yeah, reverse shift switch. Well, that's a switch for it. But this is a gear position switch. There's a big switch on the back of the engine, it looks like. I looked this one up. It's really expensive if you need it. But this is the one that's providing feedback to tell it what gear it's in. So The angle sensor apparently is pretty important when it comes to this stuff. I'm still not 100% sure what it does in relationship to the gears, because you would think that this would be all the input it needs, you know, the input on gear shift and so forth, but yet it needs this angle sensor to tell it some sort of feedback. I don't know what VCC1 means, or SPNSIG, or SGND, or IND. Well, that's a different one. But this angle sensor being those three terminals, and the fact that it does have some sort of a clocking to it as far as what it does when that shaft turns, is obviously important in telling it what gear it's in. Maybe it verifies what gear you're in, and then allows it to, you know, tell you certain functions or information, because I'm pretty sure this display is pretty, you know, unfortunately pretty knockered, but when it wasn't, I'm pretty sure that there's something on here that tells you when to shift, because it's all manual electric shifting. I'm pretty sure something comes on that says shift, and the speed sensor would have a lot to do with that, but maybe this angle sensor has to do with that as well. It tells it what gear it's in at that time, or it's in the process of changing gears. I don't know what it really does, this angle sensor, but you know, the code 3 shows that it's an angle sensor related problem, so that's where we're going to start with at least. I may off camera run some diagnostics on the rest of this 22-pin connector using the troubleshooting guide and the manual, and see what the values are, and maybe even some voltages, hook it back up to battery. But I'm not going to show any of that. I'll report anything back if it jumps out. If not, we'll just continue with this. But right now, let's take a look at the resistance on this angle sensor and see if this is obviously a potentiometer. So we'll see if it's a smooth operation. We'll try to find two wires. There's probably a high and a low side to it, so or a side where the resistance is low when it's clocked one way and high the other, and then a common or something. We'll try to figure that out, and then see how it actually operates, smoothness, and look at the meter. And of course, if it's jumping all over the place or it's not giving us any reading at all, that really helps confirm that this is a bad sensor. Okay, I think SGND is sensor ground. That's the blue with the green. That makes sense. SPN SIG is like sensor position signal, something like that. And I still haven't figured out the VCC1. I'm not sure what that is. Voltage? I don't know, some sort of voltage going into it. Obviously, it has to have some sort of voltage passing through the signal coming back out, because it's a potentiometer, essentially a variable resistor. So it's going to output a different voltage, and that's how it's reading what position it's in. So obviously, we're going to go between those other two terminals, because I've got a connector hooked up to that blue with the green. All right, I had to move over to the bench so I could actually hold the sensor and plug it in with a couple of terminal ends. So what I want to do first is I want to reduplicate this test that we did earlier from the ECU connectors to the angle sensor, which is this angle sensor inspection of the ECU connector, where you go between the, let's see, the black with the red and the blue with the green, which are the two opposite ones here, and then the yellow with the blue is in the middle. We'll get to that in a minute. And the way it looks to me is that you know, based on the wiring diagram, as I said, this would be the ground that I have the black lead hooked up to. And the one we're about to test is, I think, the voltage, where the voltage comes in. I'd have to test the wire itself, and I might do that at a later time. I have to plug that ECU back in, fire it up to power, and see what it reads there. There is a voltage test where you're supposed to tap into the wires, but I don't have that breakout connector, as I said, so I really can't do it. Honda special tool, of course. All right, so now we're connected to the two wires we tested, and it says, you know, when it was on the unit, and it's, you said unit, and it says 4 to 6 kilo ohms, and we're right in that area. And if we turn this, it doesn't do anything. So I would think that that is definitely not the potentiometer side of this, because it doesn't move. The voltage and the ground. So it's just testing the resistance of that side of this you know, this, what is it called? This sensor. So now what I'm going to do is, there's no test for this, but I'm going to go and hook up to the signal, which is the ground and the signal side right here. And we'll do it the other way too, from the signal to the what I think is the voltage side. And right now it's showing 5.7 or so kilo ohms. Let's go all the way to the left. 5.6. Turn it to the right. Oh, what did it just do? 4.4. Shouldn't be doing that. It's going out of limits, like it's not seeing a connection in that potentiometer in those spots. I'm turning it real slow. You go all the way to the right here. Oh, there it goes again. And it's certainly not the speed of me moving this. I can go back over here and wiggle it fast and it doesn't do that. There's flat spots, I think, or dead spots in this potentiometer. As soon as I touch it, when it's all the way over to the right, which with this down here is about the 1 o'clock position, 0.420, 0.3. If I touch it, just tap it. Yeah, that just is weird. And we just move it again. Yeah, it's got to be a dead spot there. I wish I could keep it, make it keep it there. Well, it's going from ohms to kilo-ohms at that point. I'm not really sure why, and that could be why it's refreshing. But if you go all the way to the right, where I'm at now, it's still in kilo-ohms, 0.4, 0.5. Now it goes to ohms, 450 ohms. Then it goes back to kilo-ohms, 0.45, and I'm turning it counterclockwise. Then 393 ohms. Then 0.5, geez, and then 0.5 kilo-ohms. Hey folks, it's me from the editing cave in the future, and I just wanted to have future me clarify something that past me was a moron about. I do realize that 0.5 kilo-ohms is basically the same as 500 ohms. Well, it is the same. And therefore, 450 would be the same as 4.5 kilo-ohms and so forth. So the meter is essentially not being naughty. It's reporting the proper amounts, but it is bouncing all over the place, which I believe, again, is indicative of a problem sensor. And I'm not quite sure why it wants to auto-range like this. I probably should have just locked it in one range or the other and tried that. But again, I do realize that at this point that it is essentially reporting what it's seeing between the two ranges, and it is doing it accurately. I just believe the sensor is pooched. You'd think that this would be a smooth transition. It would be linear. Then we're back into kilo-ohms now. 1, 2, 3. So up here it seems to be much, I guess more stable. I don't know. This is very weird. It doesn't give you any guidance in the data on this, so I don't know what I'm just spitballing right now. I think a sensor should not do this ever. See, right there it stayed in kilo-ohms, but it lost connection. So I'm pretty sure that this is diagnosis that our sensor is probably bad. Let's put it back in our starting position. What I want to do now is move these around and put this over here on that, I forgot what it is now, but we'll take it off the ground and go from the signal to the voltage. I guess that would be the way it's called. And we've got 0.6, 0.5, 0.7, and I'm rotating it to the right again. It's repeatable. It's at the exact same spot when I clock this. Not every time, but yeah, it seems to be in the same spot in the rotation, like clocking it, It gets over to about the 3 o'clock position and it does it. So like I said, I think, we don't know what the readings are supposed to be except that one, which it does come up normal, comes up proper, between 4 and 6 ohms, kilo-ohms, which it did between those two wires, which I think, again, is the voltage and the ground. But as far as the sensor part of it, which is the center terminal, I'm pretty sure, it's definitely screwing up. I mean, there's something wrong with this. So I'm pretty sure we made the right call here. We won't know 100% until I get the new sensor in a couple of days, but still an interesting experiment nonetheless. Let me go pick up nuts and bolts and put them in a baggie so I don't lose them, and then we'll just wait for that sensor to come. The manual, or the literature I should say, gives you a test sort of like we just did. Removing the switch, putting it on the bench, and checking the resistance between the yellow and blue and the blue and the green terminals. So that would be the two on the left in the orientation we were putting them in. But we tested it both ways. So we did an extra test that's probably not necessarily as valid, but we had the same problem on both of those though, where we had those spots where it went into OL and it would jump around between ohms and kilo ohms, and it just doesn't seem right. And it doesn't give you any numbers, but it says, you know, check that side of it for any damage on the spindle. There is none. You know, turn it slowly and, you know, decreases one way, increases another way, and the resistance increases smoothly or decreases smoothly. I can't say that that's smoothly. You know, the way it was all jumping around, they don't give you any numbers, but that is definitely not smooth. So also, while I was in here, I went ahead and just hooked the ECU back in place and put it back in its rubber, you know, mount. We don't really need it anymore. We've done all those tests. I did check the voltage here on the two wires. It says the black and the red and the blue with the green, and I get almost 5 volts exact. So it's right in the middle of this 4.7 to 5.3 volts DC. So that's good too. So what I'm getting to in all this fuss and muss is just to help verify that this is a bad sensor, which I'm pretty 99.9% sure it is, based upon what we find on here as far as all those checks coming up right. The resistance check we did on those particular wires, I forgot which ones, shifting it the other day and earlier in the video, and also the bench testing of this thing. So I think that's going to solve the problem once we get it in, but we won't know 100% for sure. Like I said, I'm not, you know, if I knew a little bit more about the engineering on this and the functionality as to what exactly the circuits do and what exactly the sensor inputs are for. I mean, I can estimate, like I said before, or really guesstimate. Because speed sensor for the speedo, and also to tell the ECU you're moving in case there's an interlock on that, I don't know. Certainly the interlock, when it's in gear, it won't start, it won't crank. I even tried just turning the ignition on and pulling the pull start here when it had stalled out there, and it wouldn't do that. So it kills the ignition, just doesn't kill the crank circuit, which makes sense for an interlock. So, you know, and then of course it powers up all your display stuff as far as the readings go. And like I said before, I don't have an owner's manual on this, but I'm almost positive I remember that this would tell you a shift light would come on when it suggests that you shift. I'll have to ask the owner that. But this, you know, that would make a lot of sense, especially with the angle sensor and with the other sensors, to tell you that it's time to shift. So all certain, these different inputs have to be essentially equal or yes. There can't be any no's in there. So that thing, apparently, this guy here is telling the ECU what position the shifter shaft is in. So if it isn't in the correct position, it's not going to allow you to shift because it's probably protecting the transmission. Because maybe it's interpreting that as between gears, like it just didn't shift all the way or something like that. And then if you did shift it and you gave it some gas, you know, it might damage the cogs or the dogs, you know, the gears, anything, because it's pretty much a standard transmission. It's got to be, or, you know, as far, I don't mean standard like versus automatic, a typical transmission where it's got, you know, it's got the shaft on the other side, and there is a conversion kit I read about where you can get rid of this servo motor and that little gearbox altogether. There's a reduction gearbox there, and then just go with a foot gear change. So that thing is just like a regular tranny on a motorcycle or other ATVs. So it's got a shifter drum, and it's got other, you know, shifter forks and the gears and so forth that slide back and forth on their various shafts to go between gears. And the clutch is kind of like a CVT clutch. So when you're going in between gears, it allows you to do that without it banging. And that's another reason for maybe all these different sensor inputs to allow it to do that. I'm not really sure how that works in relationship to the clutch though. But, you know, all these things got to work together. There's also a conversion kit you can get to eliminate the angle sensor altogether. It's a bypass kit. It comes with some weather pack connectors, one of which looks like it goes in here on the you know, the listing or the sales ad I saw in a couple different places, and some other connectors that go I don't know where. I think you essentially eliminate most of the connectors that are dealing with this ECU back here, because again, that thing is really exclusively for display and electric shifting. And then you just hit the button or you put a toggle switch in, and I've read some guys on forums did that, just override the whole thing and go direct. But we're going to try to keep her as factory and safe as possible. So if it's just a simple sensor, which is rather inexpensive, I mean, it's pretty cheap, even an OEM one, this will be an easy fix, except getting at the damn thing, of course. But now I got that inner fender out, it's a little easier. yeah, so I think that's where we're at. And if you guys know any more about these, as far as, you know, you've kind of delved into the electrical side of it and what each function is relative to the inputs on this ECU for the shifting and whatever else it does, I'd be very interested to hear about it, because I honestly don't know, and I've tried looking it up and I can't find it. So how this talks to that and this, and I don't know. But if you guys know, let me know. Otherwise, we'll fire this back up when we get this new sensor in. I'm not going to show you putting it in. You've already seen me wrestle with it getting out. We'll hook it all up, and we'll probably just go through some gears on the lift here. We can do that. Just, you know, click, 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 click. If it doesn't error out in a reasonable amount of time, then we'll put the thing back together, take it for a ride, and make sure that it stays that way. All right, folks, she's fixed and works perfectly. I'll explain what happened here, because this is going to be rather anticlimactic. Here's the old sensor. Now, you remember from the earlier clips, we tested the resistance of this potentiometer. I wanted to do that with the new sensor. So before I turn the camera on here, I decided to test it, you know, so I know what I was talking about at least, which is hardly ever. And I hooked it up to the meter, and I got no changes in resistance at all when you turn the center section. Remember, this one has a certain clocking range. It'll go, I don't know, maybe 3/4 of a turn one way or the other, and then stops. Well, I marked the new sensor as far as where it was set up, this little flat. You know, you can see I got a little light problem here, and then I started turning it, and I made sure that I was able to set it back to where it came out of the package, and it does not have any stops. It'll just turn and turn and turn. So I'm like, what the hell? So I'm thinking it is a defective sensor. Not that it wouldn't, you know, stop turning, but it's not reading any resistance. You know, I reviewed the service manual procedure. I went between different pins, and it just would not read anything except one set value, whatever the two pins were that I was on. So I'm fixing to, you know, get a little upset, and that never happens. And so I decided to Google it instead, and some kind soul somewhere that knows a hell of a lot more about these than I do put information up on a forum. And a technical service bulletin from Honda. 2014, they changed from a potentiometer style to a Hall effect style sensor. That's why it spins around and around, number one. And number two, it does not read because it needs a 5-volt reference to read whatever it's outputting as far as resistance goes. So instead of the potentiometer varying the resistance of that voltage, the Hall effect sensor does it in the way those sensors do that. So again, it needs the 5-volt input for it to do that. And the reason why, according to the TSB, is to minimize failure of this sensor due to vibration and other factors. So it is definitely the right sensor for it, because on the parts fiche for 2003 Rancher ES, which is the TRX350 TE, it shows that new angle sensor as the proper sensor for it. So they've updated the parts fiche to reflect it. And of course, 2014, I think it was 2014 and above, it comes as a standard equipment. So it definitely works with that ECU, and it works really great. So I'm real happy that this is done. I changed the oil and I changed the filter as the customer requested. So right now I'm going to let it cool down a bit, and then I need to degrease some stuff around the engine from oil and stuff. Because once you take the sensor out, it'll dribble oil. I just put a pan underneath it. I said, the hell with it. Who cares? I'm going to change the oil anyway. And yeah, so we're all set, ready to go. I'm gonna give them a call here in a little bit after I finish it up and do the ticket. But yeah, all said and done. Again, anticlimactic. I really kind of wanted to show you the difference in resistance, but I did not know that this was changed. And I'm glad I reviewed online before I jumped to conclusions. All right. Okay, so this video is officially done. The ATV job is officially done. And I hope you enjoyed it. I hope you learned something. Hope you got something out of it. I sure learned something out of it from doing the work and figuring out that things change over time. It is what it is, right? But as long as the customer's happy, I'm happy. I'm sure he'll be happy the way it's performing because it's flawless. Works great. So I hope you found this video to be not necessarily flawless, but beneficial. That's a good word. And if it was, you know what you need to do. You stick around the channel for more stuff like on the Z1R and the 900 and some other stuff I got going on. There's also a new tool in the shop, maybe. And so we're going to be covering that in the video. So yeah, you stick around, subscribe, ring the bell, like and share. That's really important to do that if you would please. Doesn't cost you a cent, helps me out immensely. So until that next time, as always, thanks for watching. Don't just repair, restore. We'll catch you on the next videos.